Hello, welcome everyone. I am ShafiqulHai, a PhD student supervised by Professor Odile Liboron-Ladouceur. I am presenting our research result on 45 gigabit per second multimode interference coupler based DPSK demodulator fabricated in silicon on insulator process. Silicon photonics has generated much interest in present time as optical devices can be made on this platform using low-cost CMOS technology that paves the way for integrating SOI optical devices with dense microelectronic circuits to increase the interconnection bandwidth between microprocessors. SOI waveguides operate in the wavelength range near 1300 and 1550 nanometer. In the picture, a DPSK demodulator on SOI platform is shown where the photodetector is integrated off-chip. But off-chip photodetector increases packaging cost and footprint of the receiver. Reducing the feature size of SOI waveguide and using low footprint 1x2 MMI couplers can omit balanced photodetection, facilitate integration of on-chip silicon photodetector, and increase the electrical bandwidth of the receiver. The FTDT simulation shows that a 6 micrometer with 1x2 MMI coupler maintains 3 dB power ratio at output from 30.5 to 32 micrometer MMI length. A 2x2 MMI coupler is also designed that gives 3 dB power ratio at 127 micrometer length. Here, the upper figure shows the change in normalized output intensity at MMI coupler output is lower than 0.7 dB with 1.5 micrometer variation in MMI core length. The bottom figure shows the layout of the passive DPSK receiver. This is the experimental setup of the demodulator where bit error rate measurement is performed using 2 to the power 31-1 pseudo-random binary sequence electrical data. From the experiment, we find that bit error rate lower than 10 to the power -9 is achieved for all 4 devices with different MMI core lengths ranging from 30.5 to 32 micrometer. The bottom figure shows that with per degree Celsius temperature variation, the demodulator exhibits 3 dB power penalty. From the simulation and experimental result, it can be concluded that MMI coupler-based demodulator on SOI maintains low bit error rate with 6.5% variation in MMI core length. Hence, they are more fabrication tolerant and thermally stable compared to directional coupler-based demodulators. Therefore, instead of using directional coupler or 2x2 MMI couplers, use of 1x2 MMI coupler-based demodulator enables greater bandwidth and smaller footprint. Thank you to all for your attention.